Okay? So, ito ngayon ang ating interpolation. So, ulitin ko. So, for 250 sa 9.5, okay, sa 250 wind speed, ang 9.5 ay negative 0.85. Ayan, dito natin siya ilalagay. For leeward, we have negative 1.72. And then for zone 3, you have 1.23 and negative 2.48. Ayan siya. Next, we will now interpolate for wind speed 290 na zone 1. So, yung 1.154, that is interpolated between 0.85 and 1.23. And then, itong negative 2.328, that is interpolated between negative 1.72 and negative 2.48. So, you do the same procedure for zones 2 and 3. And after that, ipapasok na natin ngayon yung truss spacing na 2.25. Now, mapapansin nyo na ang truss spacing natin ay 2.25 meters. That is very close. So, we will explain that later on kung bakit naging 2.25. Okay, so let's tabulate the wind forces or your PNet 9 forces. Para sa area 1 or zone 1, so yan yung 1.154, tsaka yung negative 2.328. Dito natin siya ilalagay. And then you have here zone 2 and zone 3. Now let's compute itong mga naka-yellow shade. Yang 3.779, that is equal to adjustment factor again, times KZT na 1, times 1.154, times your spacing na 2.25. Okay? And then yung 7.623 naman, same equation. Factor times KZT times negative 2.328 and times L na 2.25. So you have 7.623. You do the same procedure for zone 2 and 3. Again, hindi na natin i-consider si zone 3 dahil yan ay nasa corners. So, itong mga shaded na yellow numbers, yan ang ating gagamitin na truss loads, and we will be designing our truss using stud. That is again on a separate topic. Okay, so that ends our seismic parameters and wind loads. Thank you for now. Now let's continue. So still on purlins and trusses, but this time we will be computing the superimposed dead loads and live loads. So again, meron tayong W tsaka B. Okay, so kunin muna natin itong mga values na ito. A is equal to, ito yung critical region. Okay, A is 10% of least horizontal dimension or 0.4h, whichever is smaller, but not less than 4% of least horizontal dimension or 0.9. So we have here 4 conditions. And then we have H, that is the mean roof height, that is from the ground to the half of the truss height. And then we have L, that is the horizontal dimension of building measured in along wind direction. I think that is B. And then we have angle theta. Now let's compute our A. So A is 10% least horizontal dimension, or that is in Excel 0.10 times the minimum of B or W. Okay, so that is 1.31. Okay. Una, that is 0.10 times minimum, open close parenthesis. Dalhin natin siya sa B. Ito yung B. Nasaan ka? Ayan, B. Tsaka, comma, itong W. Then, close parenthesis. So, that is 1.31. Next is yung 0.4 H. So, 0.4 times H. Nasaan si H? Nasaan ka? Ayun. So, si mean roof height is 10.7. And you multiply that by 0.4, you get 4.28. And then, finally, 4% of least horizontal dimension in Excel, that is equal to 0.04 times minimum of B or W. Okay? And that is 0.52. Ngayon, hanapin mo yung minimum dyan sa tatlong yan, and we have 0.52. But, take note that it should be but not less than 4% or 0.9. Notice that 0.52 is less than 0.9. Kaya, gagamitin natin ay, obviously, 0.9. Okay. Next. Ito naman ang ibig sabihin ng positive pressure. Ang ibig sabihin ng positive pressure is pushing towards the roof surface. Ang negative pressure naman, hinihila niya yung roof surface away. Okay? So, yung zone 1, yan yung, take note, yan yung nasa gitna. Generally, it is the general area. And then, yung 2 naman, zone 2, yan yung critical region defined by distance A. Okay? So, ang ibig sabihin yan, yung A, yung distance na yan. Okay? Next is, ito. So, building width is 13.5. Bottom chord length, W, 13.1. Truss spacing, 2.25. Purlin spacing, 0.8. And height of truss, 2.2. So, naglagay na rin ako dito ng computation ng roof slope. So, we need those things. Now, we compute the superimposed dead loads. So, this is taken from table. Now, we compute the superimposed dead loads. This is based on table 204-2. So, ang mga nakapatong sa trusses, you have the roofing and insulation. Ito rin ay nakapatong sa purlins. Okay? So, we have GI roofing and insulation. From table T204-2, ang gagamitin natin ay 0.12. So, that is gauge 20. And then, you have one. Okay, let's continue. For superimposed dead loads, this is from table T204-2. This is applied on the purlins. So, nakapatong po dyan ang GI roofing, that is gauge 20 na metal, assume deck. So we have 0.12. This is in KPA. And then you have 1/2 inch insulation, or that is polystyrene foam. That is 0.004 times 25.4 divided by 2. Okay, ayan yun. Yung 0.004, ito yung, ano nga ba ito? Yung weight per millimeter, 0.004. So, mapansin nyo dun, 25.4 divided by 2, or that is 1/2 inch. Okay? Next, yung sum niyang dalawa. Now, let's go to superimposed dead loads. This is taken from table T204-2. Sa purlins, ang binubuhat ng purlins, you have roofing and insulation. So, yung GI roofing, gagamit tayo ng gauge 20. So, this is 0.12. Galing yan sa T204-2. And then, 1/2 inch insulation. So, that is 0.0004 kPa per 0.004 per millimeter. Ano? So, ayan yun. And then, multiply natin siya ng 1/2 inch. So, that is 25.4 divided by 2. Next, i-add mo yung dalawa. So, 0.12 plus 0.00508. You have 0.125. So, ang unit niyan ay kPa, or that is kilonewton per square meter. Next, ang binubuhat pa rin ng purlins yung ceiling and utilities. Mapapansin nyo na in between trusses, saan nakatali yung mga ceiling? Nakatali ba sa bottom cord? Hindi mo naman pupunin ng bottom cord yung buong ceiling, di ba? Wala namang bottom cord sa entire ceiling. Take note na yung trusses, meron niyang spacing. Kaya, in between those trusses, yung ceiling mo, naka-tie wire yan or naka-hanger yan, and ito ay nakasabit sa purlins pa rin. So, consider natin yung ceiling and utilities. So, ang nilagay natin dito ay wood flooring, or that is 0.12, that is from the table. And then, gagamit tayo ng 1/4 inch marine plywood. So, this is 0.006 per millimeter thickness. So, that is 0.006 times 1/4 inch. And then, gagamit tayo ng mechanical duct allowance na 0.2. Yan naman ay para sa lighting, etc., mga cables, so forth, and so on. And then, you add those, you have 0.358. Next, i-add mo na yung lahat na yan. And you have 0.48318. This time, you multiply that with your spacing S na 0.8, and you get 0.387 kilonewton per meter. So, meron na tayong uniform load. So, ito ang ilalagay natin sa purlins. Next, punta naman tayo sa live load. Ang live load naman, i-consider natin yung length of top cord. So, 6.909. Nakuha natin yan based on the bottom cord length tsaka yung height of truss. Okay? So, that is the length of the top cord. Isang side lang. Okay, next, ang tributary area naman, that is equal to B times W all over 2. Okay, so that is B times W all over 2. Next, based on method 1, our live load is 0.6 kPa. Okay, 0.6 kPa. So you multiply 0.6 by the spacing S tsaka yung cosine theta, and you have 0.455 kilonewton per meter. Again, this is for purlin load. Now let us summarize all our purlin loads. So we have 0.387. This is SDL. SDL means superimposed dead load. And then we have live load. And then we have WL1 na 1.749. Nanggaling yan dito sa ginawa natin kanina. Ito. Yan, 1.749. Itong dalawa. Now, split ko lang muna ito. U. Split. Para maipakita ko yung dalawang yan. So, babalik tayo sa baba. Dito. So, WL1, that means, okay, windward pressure. Okay? So, ito yun. Maximum among these two. Now, we go to WL2. Yan naman yung leeward. Okay? Leeward means suction. Hihigupin niya yung roofing mo. So, for zone 2, we have 4.873. Ayan siya, under zone 2. And then we have 2.926 para sa zone 1. Ngayon, mapapansin nyo, yung WL1, pressure 1.749, that is applied over the entire surface. Para sa leeward naman, meron tayong zone 1 tsaka zone 2. So, mapapansin nyo na yung zone 1, 2.926. Yung zone 2 naman, yung critical region, 4.879. Ito yung mga nasa gilid-gilid. So, ayan, mas malaki siya talaga. Next, we now go to the trusses. Okay. Sa trusses naman, so I will remove this split. Para sa trusses naman, ang binubuhat ng top cord, you have the roofing and insulation, which is 0.125, and that is nakalink dito sa purlins. Ayan, okay? 0.125. Next is yung purlin itself. So, ang based dun sa design na gagawin natin on a later topic, ang ginamit nating purlin ay LC 100 by 50 by 15 by 2. Ito yung pangalan niya sa steel table. Okay? So, or in inches, that is 2 by 4 by 2 mm na C purlins. Ang weight niyan ay 3.417 kg per meter. Okay, so that is in kilogram per meter. Now, you convert that weight to kilonewton. This time, I will use parentheses. 3.417 times 9.81 divided by 1,000. Then, divided by 0.8. Okay, correct. Next, binubuhat pa rin nung top cord is ceiling and utilities. This is taken again from your purlin loads. Ayan, 0.358.